When we try to deal with a partial fraction question, the first thing that we should do is to check that the expression that is given to us, it is a proper fraction. Because if it is not, that means if it were to be an improper fraction, the first thing that you need to do is to carry out a process of long division before the partial fraction process. And the expression that we are given here now, it is actually a nice proper fraction, so we can immediately change it into its partial fraction. And there are actually two possible partial fraction expression that these can be changed to. The first possible expression is for x squared, I can rewrite it as a over x plus b over x squared. As for x minus 2, I can write it as c over x minus 2. This is one possibility. Another possibility is for x squared, I can write it as ax plus b divided by x squared. And for x minus 2, it will still be the same. It is c over x minus 2. If the question didn't mention anything and you are able to make the choice yourself, you can either choose this or this. But for this particular question, it is mentioned to us that we are supposed to re-express this as the sum of three partial fractions. Which means that the choice is obvious. I'm going to go for this expression. So for now, I'm not going to use this. So for this expression that we have chosen, let's try to multiply both the left and right hand side by the denominator of the left hand side. So for this, I'm going to multiply it by x squared x minus 2. So it is going to be x plus 2 squared. And this, if I were to multiply throughout by x squared x minus 2, this will become ax. And x minus 2, this will be b multiplied by x minus 2. And this is going to be cx squared. The next thing that we are supposed to do is to solve for the values of a, b, and c. There are two ways that we can do that. One is to substitute values of x, creating simultaneous equations for us to solve for a, b, c. Or we can actually expand the right hand side and just compare the coefficient of the left and right hand side so that I can come up with values for a, b, and c. For this particular question, I think it is probably easier for us to substitute values because I can see possible convenient values of x that I can sub in so that I can immediately get either a, b, or c. For example, if I were to let x be equal to 0, letting x be equal to 0 on the left hand side, it is going to be 0 plus 2 square. And this, it will disappear because this is 0. And for this, it is going to be b 0 minus 2. And for this, it will disappear. So immediately with x is to be equal to 0, I will be able to solve for b. This is a convenient values of x that we have observed, and because we have observed that, that's why b is simply equal to minus 2. Another possible convenient value of x that I can see is x to be equal to 2. If I were to let x be equal to 2, on the left hand side it is 2 plus 2 square, and on the right hand side this is going to disappear. This will also disappear, and this is just c multiplied by 2 squared. I have an equation in terms of just c, so I can solve for c. c is going to be equal to 4. After utilizing x is equal to 0 and x is equal to 2, there's actually no more convenient values that I can apply so that I can solve for a immediately. But the thing is, we have already solved for b and c, so I'll just need to substitute any other values of x. Probably I'll go for 1. So let's try. If I were to let x be equal to 1, on the left hand side it is just 1 plus 2 square, and on the right hand side it will be a multiplied by 1 and 1 minus 2 plus b. b is minus 2, so it will be minus 2 and 1 minus 2 plus c. c is 4, so 4 times 1 squared. I have an equation in terms of just a. On the left hand side is 3 squared, so it is 9. And then this will be minus a plus 6. So a is going to be equal to minus 3. And now we have our partial fraction, x plus 2 square divided by x square x minus 2. This will be equal to a is 3, so minus 3 over x plus b is minus 2, so minus 2 over x squared, plus c is 4, so plus 4 over x minus 2.